Okay, so I chose ocean acidification as my topic because I'm pretty passionate about transitioning to renewable and clean energy, and that has everything to do with ocean acidification. So the title of the article I chose is "The Ocean is Getting More Acidic, What That Actually Means" by Eric Nyler for National Geographic. We've already talked about it in class, but I wanted to quickly review what ocean acidification actually is. So the ocean is a carbon sink, meaning that it's going to absorb the carbon dioxide that's in our atmosphere. And as all of you know, the burning of fossil fuels will release more carbon dioxide into our air, and around 30% of that is going to be absorbed by our oceans. The excess CO2 from the excess industrialization is what causes ocean acidification and lowers the pH level of the water. So on the left, you can see that the CO2 arrow in the late 1800s is very small, and then the one on the right in 2100 is projected to have a much larger magnitude. The reason I chose this graphic is because in the past 100 years, the pH level of the ocean has reduced from 8.2 to 8.1, which is, according to the article, a 26% decrease because the pH level is logarithmic, or the pH scale is logarithmic. And in the next 100 years, it's expected to decrease from 8.1 to 7.7, which is a pretty drastic change. So what does this mean for us in our oceans? So there are many organisms in the ocean that have a calcium carbonate shell or limestone, same thing, and this will dissolve in highly acidic waters. So examples of these animals are like the oysters that we studied in our last lab, or pteropods or in corals. And this is important because if they can't survive, then the organisms that are higher up in the food web, higher up in the food chain, can't consume those organisms, and then fishermen can't fish for those larger fish, and then they can't sell those fish, and then those economies will suffer and won't be able to sustain themselves. So it doesn't just affect the organisms that are actually dying in the ocean, it affects all the way up the scale. So to solve this problem, there obviously needs to be a huge reduction of burning of fossil fuels, which is why I'm such a huge advocate for clean and renewable energy, such as wind, solar, hydroelectric, although dams, there are probably already too many dams, and nuclear energy as it develops. And if you're interested in this topic, I encourage you to look into carbon capture and sequestration, which could possibly reverse the effects of too much carbon dioxide in our atmosphere. So that is my presentation. Thank you.